Hi, my name is Riley Payne, and this is my lab report for Lab 2 in Physics 2211. The purpose of Lab 2 was to compare the difference between observed and predicted motion of an object. It's different from Lab 1 because this experiment had an x and y component of motion, whereas Lab 1 just had an x component of motion. Models used include Newton's second law, the velocity update equation, and the position update equation. The observed and predicted position of, or positions of the dry eraser, which was the object we used in this experiment, were relatively similar to each other. However, the predicted y position was slightly lower than the observed y position. So we used Newton's second law to calculate the force due to gravity that was acted upon the dry eraser during the course of the experiment. We use the velocity update equation to calculate the velocity of the object at any point in time. And the velocity was changing this time because there was a force of gravity that was acting on it. And the position update equation was used to determine the position of the dry eraser at any point in time. So these are the initial positions and velocity. The mass of the dry eraser was 0.025 grams, the delta T was 0.01654 seconds, the system was the dry eraser, and the surroundings was everything else. So for this experiment, we took a video of a dry eraser being thrown, we tracked the motion in Tracker, and then calculated the average velocity using the initial position, the highest position where velocity was 0, and the final position. We then used this average velocity to calculate the initial velocity, and then used that as well with like the velocity update equation and position update equation to predict the position of the dry eraser at different points in time in GlowScript. And then we compared the observed position with the predicted position. So this is the code in GlowScript. So Newton's second law was used to determine the force due to gravity felt by the object, the dry eraser. The velocity update equation was used to determine the velocity at any point in time. And then the position update equation was used to determine the position at any point in time. So we found that the observed x position of the eraser was nearly identical to the predicted x position, which I thought was pretty interesting. The observed y position, however, was definitely higher than the predicted y position, although it was still pretty similar. The most likely source of error in this experiment is definitely air resistance. Air resistance is another force that was just not accounted for in the calculations, and this would just definitely throw off the force due to gravity. It would make the acceleration much less than it was in our calculations. So I think that's the main reason. Other possible sources could have been human error in measuring the eraser's position in Tracker. There may have been a possible z component to the velocity that wasn't accounted for. And then the mass of the dry eraser may have been inaccurate since it wasn't actually measured in the lab. It was estimated based on online information. So terminal velocity is when drag becomes equivalent to the force of gravity. And because they're equivalent to each other, there's zero net force, at least in the y direction. So the object remains at a constant speed in the y direction. The eraser never reached terminal velocity, which is best shown by the y position versus time graph, which shows that basically the trend line of the velocity was exponential the entire time. And if the velocity was constant, then there would be a linear portion towards the end of the graph where it reached terminal velocity, a constant velocity. If I were to design an experiment where I did measure terminal velocity, I would use a light and flat object, like maybe a coffee filter. A coffee filter would, since it's light, it would have a much lower force of gravity because of Newton's second law, and then because it's flat, it would have a much higher force of drag. So if the eraser was thrown straight up with the same initial speed, it would take longer to reach the floor than this experiment. Since the initial velocity had both x and y components, the magnitude of the velocity would be greater than either of the components. So therefore, the magnitude being used completely in the y direction would be higher than the magnitude or than the components of the y direction in this experiment. And therefore, it'd just take longer to reach the floor. And then the predicted and observed motion of the eraser was roughly similar to each other.